Okay, so we got an easy problem here. It's called a two-sum. So the problem here is saying given an array of integer nums, so we got an array of integer, and an integer, which would be a target, named target, will return the indexes of the two numbers such that they add up to the target. You may assume that each input will have exactly one solution. So given any array, there's only one solution. And you may not use the same element twice. So the same number cannot be used more than once. You can return the answer in any order. So here we go. So this is the example. This is the array, and this is the target number. So the target is 9, so we're looking here, the output will be 0 and 1, which would be index 0 and 1, which equals 9. Same thing, this is the array, and the target is 6. Our output is going to be index 1 and index 2, which will give us the answer of 6. Same thing for this array, which would be index 0 and index 1 together is going to give us a target of 6. Our constraint is we got maximum number, minimum is going to be 2, and the maximum is going to be 10 to the 4. The index for the array will be between negative 10 to the 9 to positive 10 to the 9. And the same thing for the target is going to be negative 10 to the 9 to positive 10 to the 9. That's the maximum size of the integer that we're going to get. Again, there's only one valid solution. The worst answer is going to be O to the n squared, which is just 2 for loops. So we're going to do the worst answer first. So we start with for I in range, which is going to be the length of the num, and we're going to subtract the minus 1. The reason we're subtracting a minus 1 is because Python is zero-based index, so it starts at 0. And if we were to just get the length of num, in this case, the length will be 3. If we were to go 0, 1, 2, 3, we'll go out of bound. So in order to stay in bound, we subtract 1 from 3 to get to 2. So it's going to be 0, 1, 2. This way, when we do the iteration, the outer for loop is always going to be in bound. Now we're going to do an inner for loop, j in range, len nums, and we're going to keep that one the same, and we're going to do x plus 1. The reason we're doing x plus 1 is because what we want is that if the index of I here is going to be 3, and instead of x is actually I. So I is going to be 3, and we want j to be 2. So it's always going to be one more than index I. So if index I is 2, then j is going to be 4. And the reason we have the length of num is because we want to make sure that all the numbers are included here. We don't need to worry about going out of bound because this is already taken care of by the outer loop. So now that we have that, now we're going to solve and say totals equal nums, and now we're going to index the array using I, and then we're going to do the same thing, nums, and we're going to index it using j. Now the goal is to find out if total equals target. If that's the case, we're going to return their index, which is going to be I and j. Now in the event that there is no answer, which in this case there will be one, in the event that there is no answer, then we're going to return an empty array. So let's see what that solution, if this gives us an answer. So as you can see, this worked out. So for all our problems here, we had 3 plus 3 equals 6. The index 0 and 1 was our output, and that's what I was expecting. Let's see for case 2, same thing. Target was 6. Our output was 1 and 2, and the expected was 1 and 2. So 1 and 2, again, what's the answer? Now let's go to case 3. Case 3, we get 3 and 3, which equals 6. Our output was 0 and 1, and the expected was 0 and 1, which this is index 0, index 1. Now let's run the code and see where I place. Again, this is the complexity here is O n square. So based on that, I placed poorly. It was 2,330 milliseconds, which placed me at 13% of all the people that have done this. Very slow. So now let's do this problem again, but now let's use O of n solution. So to do an O of n solution, we're going to use a dictionary, and we're going to call it O n maps. And the dictionary declaration there. Now we're going to use a for I. And instead of using a range, we're going to use enumerate, because enumerate is going to give us the index and it's going to give us the number of the array. So now we have this, and then what we're going to do is we're going to find the complement, which is going to be the target minus the current number. And then if the complement is in nummap, then what we're going to do is we're going to return the index of nummap and the complement, and we're going to return the index. Now in the event that that is not the case, what we're going to do is we're going to store the current number as well as its index. And if again there is no solution, we're just going to return the empty array. So to go over it, just to give an example, we're going to use 3, 2, 1. So let's say this is what we're looking for. 3, 2, 1. So let's say we start here, which is going to be it. The number is going to be 3. And then let's just start with the index. So the index is going to be 0 and the number is going to be 3. So now we're going to go to the next line here, and we're going to get the complement is going to be based on the target, which in this case is 6. Is 6, no, yep, 6 right here. So we got 6 minus 3, which is a number at index 0, is going to give me 3. So now we're here and we're saying if complement, which in this case is going to be 3, which is the same also as what we currently have, which is the number. So if 3 is in nummap, then we're going to return this. But we know that we don't have anything in the nummap. So what we're going to end up doing is we're going to do nummap. We're going to store 3, which would be the one that we found at index 0. And we're also going to store the index itself, which is going to be 0. So then we're going to go again. And now we're going to go to index 1. And at index 1, we got 2, which is here. So then what we got here is we're going to do target, which is going to be 6 minus 2, which is going to give us 4. So now what we're going to do here is going to say, okay, 4. Is 4 in nummaps? We already know that in nummaps, all we have so far is just 3. So the answer is no. 4 is not in nummaps. Since 4 is not in nummaps, we're going to store 2, which is our current number here that we were subtracting from target to find the complement. And we're going to store the index, which is going to be 1. So again, we're here, we just stored it, and now we go back to the for loop again. So now we go to the array and we go to, so now we're currently at index 1. Now we're going to go to index 2. So index 2. And what is at index 2? We got the number 4. So then we're going to subtract from 6 minus 4, and we're going to get 2. So now we go back here and we say, okay, well, it's 2 in nummap. We know that 2 is in nummap because we just stored it and we got index 1. So based on that, the answer here, this is going to run true. So now we're going to return nummap and the current index. So nummap, the complement, is going to be 2. And when we do this, this is going to return the index of 2, which is going to be 1. And then I is going to be the current index of 4, which is 2. So the answer is going to return, the answer is going to be 1 and 2, which is 1 and 2 right here, which is 2 plus 4, and it's going to give us 6. And that's how this function will work. So now let's delete that example. And now let's run just to see the test cases here, see what we get, if it works. And as you can see, the test cases all work as well. They're all green, 1, 2, and 3. The output and the expected are the same. So now let's see what we get in regards to more. It's tested against other. So now we went from being this far off to now we have one of the best solution, 3 millisecond. It'd be 62%. Again, this right here changes, so depending on how often you do it, who you compare it to, sometime this could be 0 millisecond and that could be 100%. So either way, it's a very good solution.